I want to dig a little bit deeper on some of the technologies you mentioned. Like you said, you had to rebuild the file system. Like I would never think that, oh, I need to rebuild the file system to get this performance guarantee. So like, oh, why did you do that?
Yeah, so first of all, like a kind of open secret is like it's actually less hard than you think to build a file system. I mean, there's like Fuse, which is like file system user space. So you can, and there's even like a Python wrapper, or like there's a Python implementation of it. So our first prototype file system we actually wrote in Python, which is a terrible idea, but it was great for like kind of proving the point, like it actually worked. Anyway, why did we build our own file system? So the problem is we want to start containers very quickly. How do containers start, right? Like a container is essentially, from a Linux point of view, it's basically like a couple of different primitives. There's a couple of things around resource isolation and security, but it's also a thing around defining a root file system and pointing to, here's the root file system in my Linux machine. Please start a container from this Linux file system. And what we realized is that the average container image is very large. It contains so many files that are never actually read. And so when you have this like pushing and pulling of container images, there's a lot of inefficiencies, like moving a lot of data that's never read. And also to some extent moving the same data, because like a lot of different containers, they actually contain the same data over and over. And so there's this deduplication based on layer, but that actually doesn't accomplish too much like in terms of efficiency gains. So what we realized is like, what if we instead build this file system that presents this file system to the container engine, but however, those files actually don't exist on local disk. But when the container engine runs C or something like that, it requests this file, then we go and fetch them over the network. So that way you can accomplish, just getting rid of, you don't have to copy all these files that are never actually read by the container. The other thing we realized is that a lot of the files are the same. So what if we checksum them, and instead of storing them based on path, we just store them based on the checksum. And we built essentially what's called, the idea is a well-known idea. Other people have been doing this since the 60s, content-addressed file system. So we built a content-addressed file system where we compute a checksum for every single file. We store that separately, and then we have index files that then resolve to this underlying blobs. And then we built this file system that presents that to the container runtime as it is, as a root file system. But under the hood, we actually go out and fetch the underlying blobs and then cache them locally on SSDs. And if you do a lot of these tricks, you can get very low latency container startup and very high cache efficiency, which means you can boot containers very quickly, which was the end goal that we wanted to get to.
That's super cool.
Yeah, and it once again reminds me of Unison. Me and Justin smiled at the same time.
Oh yeah, because they also have some sort of like checksum based. Yeah,
Yeah,
I
they do.
remember reading about it. You're right. Like it's pretty interesting. Yeah, it's a content address thing. Yeah.
That's super cool. Like you basically made a lazy file system, which one of the biggest things in performance is just make things lazier, and that'll make it faster. And it seems like you guys took that to the extreme here.
Yeah, totally. It's kind of like a CDN in a way. Like we think of it as a CDN in many ways.
That's awesome. I feel like this is a space that definitely should be explored more. I've seen some really creative experiments with people just playing around with Fuse, just like building really cool stuff. And it's like, yeah, file systems are really powerful, and there's a lot of things that you could do with them potentially. And this is such a great example of that.
Yeah, totally. And our file system is proprietary, but I think there are some open source ones where people have been trying to implement this within Kubernetes and within Docker. There's a project called Nidus, and there's another project called Dragonfly, I think, something like that. Maybe it's the same thing. So there's like, and then there's another file system called like StarGZ or something like that. So there are some attempts to implement this within the existing sort of Kubernetes Docker realm. I don't think it's widely used, but it's sort of interesting to see like these ideas are in a way like kind of, if you actually go deeper and like think about it, like I think there's a lot of people who have sort of arrived at the same conclusions.